Hi, and welcome back to the channel. In this video, we're going to be covering what seems like a basic problem, but is actually a pretty complex one when we start to think about it through a lens of Python, and that's going to be working with what we call named tuples. Now, if you don't know what a named tuple is, or if you're here in this video to learn about named tuples, then look no further. We're going to cover A, what they are, B, why they are useful, and C, what some other alternatives are out there, what their strengths are, what their weaknesses are. So before we jump into everything, let's first take a step back, not talk about named tuples, but talk about a general problem in which named tuples are going to be a potential solution. So the problem is this: we've got a list of kings. Now, this is a fairly simple problem. We want to store their names and their ages at death as Python data. And more importantly, we want to use the strengths that Python offers. We want the data to be easy to read and easy to write. So on a very simple, naive, or a basic approach to this problem, you might be thinking to yourself that you can store a list of different individuals. Let's call one of these kings Charles, like Charles the Great. We can give him a name of Charles, and we can give him an age at death of 72. And I can print this off, and I'm going to have data. Now, I can consistently, while I work with data, keep on creating this basic tuple here, or list here, where I'm going to have Charles in the name in the index 0, or the first position, and I'm going to have the age in the second position. Now, let's go ahead for right now and just make this an integer. So it's not going to be a string here, rather an int. Now, everything works great. This data is somewhat easy to read. It requires a little bit of extra knowledge though, right? I have to know that something that is in position index 0 is going to be a name, and it should probably be a string, and I've got something in index 1, and it's going to be the age of the person at the time of their death, and it should probably be an integer. However, this requires a lot of information that's not very obvious in the data. 72 could refer to age at coronation. It could refer to a bunch of different information that might be stored as an integer. So one of the things I could do is I could realistically say index 0 is going to be equal to the name, and index 1 is going to be equal to age at death. So I can add some extra documentation in here that makes this a little easier to parse. So this is one way that I could store the data. But it's not very good because it requires a lot of extra information, or requires a lot of extra documentation. It's not necessarily going to be easy to read. You're going to have easy to write. You're going to have to constantly create a bunch of different objects this way in your Python script, or iterate over a bunch of external data and kind of create this architecture. Now, another approach to make it a bit more easy to read is to use maybe a dictionary. Now, in a dictionary approach, we could do something like this. We could again have an object called Charles, and we can say name is going to be relevant to Charles, and let's just say age, to keep this simpler, is going to be equivalent to 72. Now, this is again easy to read and easy to write. Now, one of the good things about a dictionary is that it's very apparent what keys refer to what values, because that's the whole point of a dictionary. Now, a dictionary, on the surface, if you're new to Python, is going to be a perfectly valid solution to this problem. However, the dictionary is going to require a little bit more cumbersome writing on your part, especially if you have multiple objects that are going to have all these different keys and values. And also, it's going to require a bit more writing and maybe even still some documentation. So what other options are out there? Well, in the collections library, this has been around since Python 2, we can access the named tuple. So I can say from collections, import named tuple. Now for right now, in collections, keep in mind, this is all lowercase. So I can import named tuple. Now, what does named tuple let me do? And for those of you who don't know, you can follow along in this GitHub repository linked down below, right here in the prepared Jupyter notebook if you want to follow along. Well, let's go ahead and copy and paste this bit over. So named tuple is going to allow for me to create some really kind of structured data in a tuple. So I can have two different things go into the named tuple class here. The first thing is going to be what the named tuple is. So what kind of I think about it as a class name here. So in this case, we're going to call this a person. We can call it a king. We can call it whatever we want. The next thing that it's going to take is a list of the values that need to be stored in that tuple. So let's go ahead and create this object right now, store it in memory. And then what can we do with that? Well, if we go back to our notebook here, we can see that we can create class-like tuples that have named attributes. So we can say Charles, let's go ahead and call this Charles1 now, is going to be equal to person. And this is going to pass in two different pieces of data. The name, just like we saw above, and the age. So let's stick with 72 once again. And I can print off Charles1, and we see that we have that data stored as a named tuple with two clearly defined attributes, the name and the age. Now, why is a named tuple useful here? Well, two things. One, it is easy to read. It's very apparent what each of these attributes are because I can access them, and I can type in .name and access that individual piece of data's name, and age and access that as well. It's also fairly easy to write. Anytime I need to create a new piece of data, I can create it by simply adding in a new piece of data. So I can say Henry is equal to person, and I can pass in Henry as the name, and then the age is, let's just make up a name and say 56, and I have a new piece of data. Now this is both easy to read therefore and easy to write. Like I said, name tuple, all lowercase, from the collections library has been around for a long time in Python. However, in Python 3.5, we got the ability to actually assign typing values to different pieces of data, meaning we can specify how that data should be rendered on the part of the user. So name tuple from the typing library is going to be a capital N here and a capital T to distinguish it from the collections library. Now again, you can go to the prepared notebook and follow along. The named library or named tuple is going to take data a little bit differently. So let's create person2 here for this second method of creating a named tuple. We can specify or call the named tuple class, and we're going to pass in a couple different things here. The first thing that we're going to pass in is, again, the name of the class, if you will. Now the second thing that we're going to pass in is going to be a list. Now this list here isn't going to be just a list of values that we want, or attributes that we want to have for that piece of data. Instead, it's going to also contain other pieces of information that's going to be a list of lists. So the first thing is going to be the actual value, so name once again, but the second thing that we're going to pass in is what that value should be, meaning what type of data it should be. And as you can see, you can pass in the standard Python data types. So in our case, str for string, and we're going to tell the user that we want to pass in age as an integer. So we can leverage Python 3.5 and greater's typing attributes. So let's go ahead and create person2 here, and let's try to create a piece of data for person2. So person2, we're going to say Charles again. It's going to be equal to person2, and we're going to pass in, again, two pieces of data. We can pass in the name of Charles and the age of 72. And once again, just like above, I can specify, actually let's go ahead and call this Charles2 to keep it consistent with our formatting here. And helps if you actually execute the cell, and we see that everything appears just as it does above. One of the advantages of the named tuple class is that it can take in these typing formats, meaning when a user is using hints, they can see what this named tuple is expecting. And again, just like before, we can access the name attribute, and we can also access the age attribute. So we have access to the exact same data structured the exact same way. Now, one of the downsides to this is that this can be a little difficult to read in the sense, or a little difficult to write out in the sense that there's a lot of things going on here that don't make it, that requires maybe 6 lines here to write everything out to make it a little legible. There is a better way that we can access this or create this exact same class structure, and that's by passing in the name tuple class to a custom class. So let's create a class called person3. And let's make this capital here. Let's just make a lowercase to keep it consistent. And this is going to take in the named tuple class. So it's actually going to what we would call inherit from the named tuple class. Now here I can pass in two things, name, which is going to be a string, and age, which is going to be an integer. Notice how much tighter this code is. So good code is both going to be easy to read, easy to write, and it should be fairly tight. Now these are not necessarily the exact order and things that you need to prioritize, but it's some good rules of thumb to remember. So just like before, I can use the method 3 here, and I can say person 3, or I'm going to say Charles 3 is going to be equal to person 3. And I'm going to once again pass in the name of Charles and the age of 72. And just like above, I can also specify, I create the class, and I can access each of the attributes just like before, and I have the exact same result. So these are 3 different methods and ways that you can go about accessing and creating named tuples in Python. But there is another 4th thing that is important to know about because you might see it out in the wild, and it's also important because if you're working with a lot of data, it can be valuable because of how things are stored in memory to know about. And that's going to be the data class property. So what we can do is we can also create a 4th method here. Let's say method 4. This is a little bonus method, and we can use what we would call a data class property. So we can import from data classes, import data class. And what can we do with the data class? Well, we can do something that looks remarkably similar. We can use the data class property, so data class. And what we can do with this is we can say class, and let's say person 4 is going to be equal to name, which is going to be equal to string, and and age, which is going to be equal to an integer here. And we can create a data class here. What can we do with this? Well, we can do the exact same thing. We can say Charles 4 is equal to person 4, and we can pass in Charles and 72. And we see that we have the exact same results, the ability to access the different attributes. This is just another method to be familiar with. Now I did some digging because I've always been a little curious when you should use data class over a named tuple, and it comes down to larger problems that aren't really covered on this channel, which deal with basically how data is stored in memory. The named tuple class is going to take up less memory because it is going to be stored as a tuple, but the data class is stored as a dictionary. I believe I'm right on this, so that you can actually access the data more quickly. So when to choose data class over a named tuple is going to come down to really when you start working with larger quantities of data, and building something that's going to be applicable at scale is going to be of chief concern to you. But when it comes time to that, you'll be able to do more research on your own and hopefully pick the right solution for your actual particular problem. That's going to be it for this video. Hopefully you have a sense of different ways we can think about structuring data in Python, how to go about doing it, when to use a named tuple, what it is. If you get a lot out of this channel, please consider supporting it via Patreon or YouTube membership. And if you did like this video, please like and subscribe down below. Thank you.